Hi, this is Patrick Wheeler, and thank you for joining us for Oracle Database World. Normally, at about this time of year, I'd be welcoming you to San Francisco. There would be hundreds of us.
Thousands!
Perhaps, packed into an auditorium.
Stadium!
As it is, I'm in San Francisco, but you're probably not. It's just me here and Zeke and Troy. But the show must go on. In this session, I provide an overview of the suite of tools that we've built into Autonomous Database. The idea is that it should all be there, at your fingertips, with nothing more to buy and nothing more to install. Now, I'd like to play you a short movie to lay out our philosophy. We've made the DBA's life easy with Autonomous Database, taking the drudgery out of the job and freeing up time to do higher value work. But there are other users of the database: data analysts, integrators, application developers, data scientists too. We didn't think it was fair to leave them out in the cold, so we've built a suite of tools right into Autonomous Database to extend the benefits of autonomy to these people too. As an ADB user, it's all right there at your fingertips, with nothing more to buy and nothing more to install. Now we turn to what you do with your data warehouse. Let's consider first the job of one of those personas, the data analyst. A swimming medley is a pretty good analogy for the process of data analysis. The first leg in the relay is to load your data. Then comes data preparation. And next, semantic modeling. Only then do you get to the anchor leg, analysis of your data. Oracle provides industry-leading tools for each of these legs in the data analysis medley. Oracle Data Integrator, or ODI, is an enterprise-class data integration tool with extract, load, transform, ELT, architecture. Enterprise Data Quality, EDQ, is a sophisticated, powerful tool for profiling, cleaning, and preparing your data. Analytic views, built into Oracle Database, provide a common framework for defining universally accessible semantic models. Oracle Analytic Cloud, or OAC, is the perfect complement, providing beautiful and insightful analysis of this data. For our traditional market, then, this is a comprehensive and compelling suite of tools, enterprise-class tools for an enterprise-class market. But we must keep in view the fact that Autonomous Database expands the addressable market for Oracle. If we draw a graph of the size of a company on the y-axis, for which number of employees is a reasonable proxy, against the number of companies of that size on the x-axis, it would look something like this. There are relatively few very big companies with tens or hundreds of thousands of employees. And there's a very large number of smaller companies. These are SMBs, small or medium businesses, or perhaps individual departments or lines of business with their own budgets in large companies. Oracle's traditional market, of course, is this enterprise space. Our ability to address the most exacting requirements of the very largest companies in the world is unmatched. But because of its simplicity and low cost of ownership, Oracle Autonomous Database now dramatically extends the addressable market. It's now very realistic, compelling even, for SMBs with small budgets to enjoy the benefits of Oracle Database. But we recognize that customers in this newly accessible market have a different profile, whereas our traditional market was perhaps the Fortune 5000, with complex requirements and large budgets to address them with. The budgets of customers in our new market tend to be smaller. Rather than dealing with enterprise IT and large central specialist teams of experts, in our new market we're dealing with shadow IT and small departmental teams, or even individual generalists. So thinking back to the data analysis medley, Perhaps in our traditional market, we could think of this as a relay medley. It's hard enough to swim a length or two of an Olympic-sized pool in any stroke at racing speed, for many of us, perhaps at any speed. And this is the big advantage of the big companies. They can afford to staff centralized specialist teams of experts in these various fields. Specialists in data integration, specialists in data preparation, in semantic modeling, in business analysis. But in the new market, we're not talking about a relay medley. It's an individual medley. Now, there are very few people who can competently swim an individual medley. It really is quite a challenge. Correspondingly, it's unreasonable to expect that our traditional suite of tools, developed to address the complex requirements of the enterprise market, is suitable for this newly accessible market. It's not realistic to expect these users to perform an individual medley. We need to rethink our approach to these requirements of this market. What is needed is an integrated suite of tools, tailored for the needs and skill set of this newly accessible market. Expanding on our analogy, perhaps we could think of this more broadly in terms of needing to cross a body of water without necessarily being very good at swimming. Perhaps paddling a canoe would be a far more realistic proposition. Okay, now let's review a little history. The Enterprise Data Warehouse. The Enterprise Data Warehouse was the zenith of the power of corporate IT. There was a promise of many benefits, global insights derived from a global overview of data, high quality threshold for incoming data, no garbage in, no garbage out. Big teams of data integrators, developers, and analysts could naturally collaborate around this central resource. It was classic, strong data management. But they were cumbersome, rigid, expensive. We all know what happened next. Budgets moved to departments and lines of business, and along with the money, so went the power. This was the dawn of the self-service market. There followed a proliferation of niche tools to serve this new fragmented market. Data integration tools with their metadata stores. Data prep tools with their metadata stores. Development tools with their metadata stores. Analytic tools, yes, with their metadata stores. And with this fragmentation of tools comes a fragmentation of data into the technical silos of the various tools in the various departments. The Enterprise Data Warehouse is relegated to one curated source of data among many others. The great leap in agility has come at the expense of data quality, consistent semantics, reliable data lineage, performance, reliability, and so much more. Our opportunity is to address this fragmentation of tools and consolidate these silos of data without sacrificing the gains in flexibility and agility that came with the self-service generation. We foresee a transition from self-service to autonomous analytics. We can address the problems that the self-service movement introduced. Now, this is a key point. Data consolidation and continuous learning from user actions are the essential foundation for autonomous analytics. This will enable us to meet our goals. Reconsolidating processing and data, re-establishing strong data management, while retaining the hard-won benefits of agility and flexibility. It's a cliché, but it's a good one. The whole is greater than the sum of the parts. The benefits of integration are multifaceted. With Autonomous Database, we deliver an integrated platform. It's not a single tool with a customer left to buy the other tools they'll need, nor is it a solution delivered in kit form with the customer left to cobble it all together. It's pre-assembled, pre-configured, pre-deployed. There's a consistent user experience with built-in best practices. It's like having an expert in the box there to guide you through. Components are defined in the common database layer. so that they can be shared by all users in all tools. And all this metadata is brought together in the catalog. So it's not just the tools that are integrated, it's the data too. A business model spanning data sources that can be federated when appropriate and defined in a common data catalog eliminates silos. The result is renewed confidence in data lineage and impact analysis. In other words, we have collaboration by design. This built-in collaboration between specialists eliminates silos. For example, hierarchies recognized automatically in the data preparation phase and defined in the database itself are immediately accessible to the data analyst for aggregation purposes. Additional semantic modeling by the analyst, perhaps defining sophisticated calculations, such as percentage change since last year. Try writing that in SQL. And again, defined in the database itself, can be accessed by the data scientist. This provides a great head start in developing predictive models that in turn can be used by the CRM developer who might want to augment a customer view with the most suitable campaign to discuss during the next meeting with the customer. So Autonomous Database comes with a sophisticated suite of tools pre-installed. But it's not a walled garden. On the contrary, it's an open platform with open standards. If you want to speak SQL, speak SQL, and so do we. We speak Python too, if that's your preference. Now, whether your data is in a CSV file or JSON format or whatever else, it's going to be comfortably at home in Autonomous Database. Using the language of your choice, analyze your data using whatever tool you're most comfortable with. The whole idea is there should be nothing new to learn. So far, I've been talking about the philosophy of Autonomous Database, and this has guided its evolution. We know you've got a plethora of data sources to wrangle. Apps, databases, files, and more. And a vast array of things you want to do with all that data. We know you expect more than a flashing SQL prompt to do it all with. And with the Autonomous Database tools, we aim to include everything you need and nothing you don't. There are tools for data load and transformation, business modeling to make sense of all that data, data insights so you don't need to go looking for a needle in a haystack. There's a catalog too, and tools for graph analytics, spatial, ML, and of course SQL Developer Web and Apex for low-code application development. Now we move from the general to some of the specifics of Autonomous Database tools. To provide some context as I do so, I'll walk through a sample business case. This is based on a notional movie streaming business named Oracle Movie Stream. Within this business, I'll be playing the role of a departmental analyst. I've just been assigned a new mission by my boss. Look into the data for Q2 last year to help us plan the new campaign. To support this analysis, I've been given an extract of consumption data from last year. In the OCI console for your Autonomous Database, click on the Database Actions button and log in, using the credentials provided when you provisioned the ADW. This takes you to the Launchpad for this tool suite. It's very easy to navigate this interface. I'll give you a quick tour. Each tool is available via this card-based interface. These are arranged in groups such as development, data tools, administration, and monitoring. There are some useful quick links accessible from this panel on the right-hand side. Context-sensitive help is available by clicking this question mark. Preferences, an About menu, and Logout dialog are available here. You can always return to this Launchpad by clicking on Database Actions at the top of the screen. There's also direct access to any tool from the so-called Mega menu, accessible by clicking on the Hamburger menu at the top left. So, what's the first step? Data load, of course. Anyone that's tried to load data knows that it's more easily said than done. Until now, that is. Just say what you want to do. load data into your ADB, link to data in a remote location, or even set up a live feed. Then say where your data is, in a local file, a remote database, or in an object store in some cloud, and press go. That's it. The bottom row of cards allows you to set up cloud storage locations, monitor data load jobs, and explore data in the ADB. We'll start with a simple load of data from local files, and then from a cloud-based object store. In this case, I'm using the OCI object store, but we can just as easily access files in AWS, S3, Azure Blob Storage, and Google Cloud Platform. This Explore capability is very helpful for profiling data that you've just loaded. After clicking on the card, we see a list of tables in the autonomous database. I click on the card for one of these tables, Movie Sales 2020, and press Statistics. Immediately, we can identify some data quality problems. We have data for 12 months. Since I only want to analyze data for Q2, I have some superfluous months in this data set. Here we see data for 14 days in a week. That doesn't sound right. Drilling in to investigate, we can quickly see the problem. Some of the days are in uppercase and others are in title case. So what have we seen here? In a few short minutes, we've loaded data both from files of various types and from multiple locations. We've quickly scanned that data and identified some problems that need to be addressed. We'll do that next. Sometimes your data is just right, and sometimes you need to clean it up a bit. Sometimes quite a lot. That's where the Data Transforms tool comes in. All the power of Oracle Data Integrator, ODI, with a nice, clean, modern web UI. Simple enough even for me to use. It's just what you want. Drag and drop to say what you want to do. Don't worry about how to do it. The tool does all that hard work for you. Here on the left we see our data entities, essentially the tables we need for our transformation. Across the top we have a tool palette. Powerful capabilities are grouped into categories such as data transformation, data preparation, machine learning, etc. This is the main canvas in which the data flow is laid out. And over here on the right, we have the detailed properties for each step in the data flow. Nice and easy. So here we've used the Data Transforms tool to fix some data quality problems we identified during the data load phase. To do this, we created a data flow, which filtered out unwanted months and standardized the case of column day. We created a new table, Movie Sales 2020 Q2, with the resulting data set. Data analysts typically don't work directly against tables in the database. It's rare for the semantics of the data model to be apparent from the physical data structure itself. Instead, analysts work against a semantic model. This is a layer above the physical data structure that defines its business significance. But not all business models were created equal. Most of the popular self-service analytics tools define the business model in the tool itself. A common problem with this is that different analysts, each with their own self-service tool, can easily define different and contradictory business models even on the very same data set. Oracle's approach is to push the business model into the database layer. There, it only needs to be defined once, which in itself is a great productivity boost. But perhaps more importantly, this promotes consistency. By sharing this common business model, all analysts get a consistent view of the business. A further advantage of defining the business model in the database is performance. A key insight is that business analyses typically access data at the top level. For example, rather than an individual customer's purchase of a particular movie last Tuesday evening, the data analyst might be more interested in consumption of a movie genre by a demographic segment of customers in North America last April. By automatically recognizing the hierarchy and defining it in the database, Autonomous Database can automatically compute and store these top-level aggregates. We call this materialization of aggregate caches. Because Autonomous Database knows about the hierarchy and knows about the existence of the aggregate cache, it can transparently rewrite queries to access the pre-computed aggregates rather than having to compute them on the fly. The result is exceptional performance, even with huge data sets, even with federated data sources. It all happens transparently, behind the scenes. All the end user does is to browse and access the data just as if it were all stored locally in the Autonomous Database and just as if it were all stored at the lowest grain. We've made it simple to build sophisticated models on your data by identifying dimensions, hierarchies and measures with a nice clean way of saying how to aggregate, sum, average or whatever. Here's a screenshot of the business model tool in Autonomous Database. We start by saying that we want to build a business model on top of the table we've just created, Movie Sales 2020 Q2. The tool automatically detects candidate dimensions based on some of the tables we loaded at the start. These are days, months, geography, devices. Candidate measures are also identified, along with corresponding aggregations, the sum or count or average. So here we have a nice candidate star schema with a fact table, 4 dimensions and 2 measures. After we've created the business model, we get a little card like this. If we click on these 3 dots on the upper right of the card, we can look into it in some more detail. A business model is implemented as an analytic view in the database. I like to look at the DDL that was used to create this thing and think how happy I am that I didn't have to type all that in myself. More interesting is to analyze the data. Here's a quick and dirty pivot table based on Q2's movie purchases. Notice how the data is broken down by customer segment and aggregated in the devices hierarchy. Let's review what we've seen in this demo, because a lot of value has been added in a brief period. The business model tool guided us through the automatic creation of a business model on top of the data we loaded and cleansed just a few minutes ago. It automatically detected a star schema with a fact table and 4 dimensions. 2 of those dimensions, geography and devices, have hierarchies, which were detected automatically and enable the aggregation of data from country to continent and device to form factor respectively. The business model is implemented as an analytic view, but we didn't have to write any SQL to build that. We could even view the data through a quick and dirty pivot table. Next comes a feature I wanted to call the electromagnet, but they didn't let me. An analyst's job can often feel like looking for a needle in a haystack. So throw the switch and all that metallic stuff is going to slam up onto the electromagnet. Sure, there are going to be some rusty old nails and screws and nuts and bolts, but there are going to be a few needles as well. And it's far easier to pick the needles out of these few bits of metal than to go rummaging around in a pile of hay, especially if you have allergies. That's more or less how our Insights tool works. Load your data, kick off a query, and grab a cup of coffee. Autonomous Database does all the hard work, scouring through this data, looking for hidden patterns, anomalies, and outliers. Essentially, we run some analytic queries that predict expected values, and where the actual values differ significantly from expectation, the tool presents them here. Now, some of these might be uninteresting or obvious, but some are worthy of further investigation. You get this dashboard of various exceptional data patterns. Drill down on a specific gauge in this dashboard, and significant deviations between actual and expected values are highlighted. Data Insights is a remarkable tool. Autonomous Database uses its knowledge of the business model, analytic view, to automate the slice and dice process that an analyst usually performs manually. The tool identifies anomalies, deviations from expected values, using ML algorithms such as regression slope, and catalogues them for the business user or analytics tool. This is a great feature for new users of ADB. Imagine creating a new data mart and then getting interesting results right away, autonomously. Data is capital, and the built-in catalogue allows you to maximize its value. This is what you see when you enter the catalogue. There's a set of cards for the most recently processed objects. Over here we have some useful links. For example, all tables owned by me, or perhaps all of my business models. I really like this search capability. It's very browser-like, so you can type in simple queries like movie sales, but more powerful searches are also possible, and this context-sensitive assistant guides you through this syntax. Here I'm looking for all objects related to devices. Now, an essential ingredient for the credibility of analytics is a clear understanding of lineage. A particular insight might appear interesting, but if it's based on a bogus data source, then it becomes untrustworthy. The catalogue tool provides precisely the detailed lineage that is required to be able to trust your data. You might think of this as a chain of custody of data as it progresses from raw data to insight. For example, here we see the lineage of the devices hierarchy. We started with a file on my Mac. We imported this using the data load tool, which created a table. The business model uses this as an attribute dimension on which the hierarchy definition is based. So this is what enabled the roll-up of movie consumption data from iPhones and Androids to the category of smartphone, as we saw in the pivot table just now. Equally important is impact analysis. Here, for example, we see the tree of dependencies for the table Movie Sales 2020 Q2. You'll recall that we created this in the data transform step, in which we cleaned up the raw data that was loaded. Any further changes to the data in that table will have cascading impact on various components of the business model, which in turn was the basis for the various insight queries that we've just seen. To summarize, use the catalogue to view objects in Autonomous Database. There's a browser-like search capability, and we can use the filter to show entities of particular types. For individual entities, we can see valuable information such as lineage or impact analysis at various levels of detail. Can you imagine buying a new car without Bluetooth, airbags, electric windows, or even cup holders? These are among the basic requirements in the modern generation of cars. But when I was a boy, cars didn't even have seat belts. Correspondingly, with Autonomous Database, we usher in a new generation of database cloud service. And with this new generation, just as with previous generations of database, we raise the threshold for minimal required functionality. Autonomous operations by themselves represent a generational breakthrough, but we believe that more is required. For this new generation of database cloud service, the autonomous generation, all users of the service require embedded functionality. All of this should be built in, with nothing more to buy and nothing more to install. It's the next generation database cloud service from the industry's leader for data management. Thank you for spending the last half hour with me. I hope that you enjoy the rest of Oracle Database World.